This right here is probably one of my favorite math problems that I've done. Probably one of the only ones that I've actually done. It was out of a book of like nearly impossible equations or something like that. And I thought this problem was really cool. I ended up doing it because in my study hall there were some people. Uh, my study hall teacher was actually joking around saying, "You guys should try this." Well, these kids were like around freshmen. Well, they were freshmen. And there were some older people, and they're like, this is impossible. So that was pretty much an incentive to do it. Guess that's how I roll. If no one can do it, then I'll try. And when I fail, then I'll be very disappointed. Well, maybe. I don't know. The first thing, well, what this problem is it's a long division problem. So everything here is just a digit. It's not really like x times x like you can see in a standard thing. So x times x, that isn't equal to x squared in this equation. X is actually just like two different digits, so it'd be like, you can denote that as like a1 times 10, and then you can denote that as a, which would be like times 1 if you want to add it that way. That's actually what it's showing here. So you don't know really any of the digits initially, but what you figure out is it's going to terminate. It doesn't even show the 0 at the end, but you know that it's going to be that way because it's a terminating problem at that point. The next thing, you kind of get a feel for how long division works again, which I did not do too much before I did this problem, so I kind of had to revisit what it was and all that stuff. So pretty much the concept, you times this number, times it by that number, and you try to make the highest number that doesn't go over this number. So this times this number would output you that number, and this times this will be the highest number possible without going over that. So you figure that out. What you also know about this long division equation right here is that you end up subtracting these two out every single interval, I guess, or yeah, part of the function. So you pretty much like would subtract that out. Well, what that means, if this minus this is 0, then what you find out is they are both going to be equal. So those are going to be equal. The next thing that you notice is in long division, when you run out of numbers over here, you actually end up adding zeros at the end, and then you drop them down. So you know that these digits are also 0. So let me put the zeros in. It will be long and tedious, so I might edit it to make it not as slow, because this problem actually takes a while to solve. 0, 0, 0. You also know that these two are going to be equal as well. Um, so we found all of this out. Once you find all that out, what you know is this times this number is going to get you that number, which is also going to end in a 0 because those two are equivalent. So now we're going to take what all the possibles of this times this would be. And since we know the result of xx times x is going to get you xo, or in standard algebraic terms, a1 times 10 plus a2 times 1, and that's going to be one quantity, which is this part right here, and then you multiply that just by a3, and that will get you something times, well, a two-digit number that's going to end in 0. So what you can do is, we're just going to look at this result and then find out what these two possibles could be. So let me erase that real fast. See how fast I erased that? Should be a professional eraser right there. Alright, so now that we got that hammered out, let's make some tables. So we know this value right here is going to be either 10, 20, 30, 40, 50, 60, 70, 80, or 90. Let me grab my calculator really fast because I'm horrible at manual computation. So I'm going to end up doing something later. Alright, I got my graphing calculator here. I wrote a Python script that would be even better to make factors than this because it only shows the ones that don't have decimals. So pretty much, but in this scenario, I'm just going to use this because I'm not going to click over to the screen, and this isn't supposed to be a whole programming segment, it's just supposed to be a math segment. So once you have those numbers, we need to find all the possible factors. So what I'm going to do in my calculator is type in y equals, and then x over whatever the number is, 20 or 10 in this case. So let's type in that here, x divided by 10. Now let's pull up the table. It should look something like that. Okay, so now once you have that, well, let me show you the formula. Okay, well that's nice. But I think you guys get it. X over 10. Alright, let's pull over to the table. Oh, I actually need to change my table set. Oh, actually do this wrong. Oh, my bad. It should be 10 over x. Okay. Feel stupid now. Okay. Type in 10 over x. My bad. Because that's just going to go 10 divided by 1, 10 divided by 2. Yeah, that's definitely wrong. So let's pull up our table. We only want positive values. Okay. So here's what I have. I have 1 and 10. So 1 and 10. And then I'd have 2 and 5, obviously. Nothing else would work. So then for 20, and we're actually trying to find xx times x. So what you eventually find out is these two are going to be extraneous right here. Those aren't going to be, they're not even possible to actually be that number and that number, because one's a 1 digit, the other has to be 2 digit. Also, what you find out, this is kind of hard observation right at this point in time, but what you also find out is since this number plus this number has to equal 0, you're not going to want this number, this number at the end to be a 0, because you have to have 0 minus something equals something. And it's not going to be 0, or else that would be the terminating point. So you also find out that anything that ends in 0 is going to be a terminating point. Well, excuse me, an extraneous answer.